Now we will discuss the unit vectors, and the unit vectors are such that when r is here in this direction, then r unit vector is in this direction. This is the direction of r unit vector. Similarly, when theta will change in this direction. So it will be the direction of theta here. Theta will be in this direction. This is our unit vector direction, and this is theta unit vector direction. And similarly, the angle phi will be such that it will be along the phi unit vector. So it will be in the direction which is very hard to show in a 3D, but it will be this inner direction, means going this way. So this will be phi unit vector along this direction, and they are perpendicular to each other. Like as we are having the xyz perpendicular to each other, similarly r theta phi are also perpendicular to each other, and now we will derive them. As I know here that r vector is equal to this, so r vector, if I divide by the r magnitude, then it is equal to r unit vector. And r unit vector will come out to be, just cancel r from all of them. So sine theta cos phi, and x plus sine theta sine phi and y, and plus cos theta in z, cos theta in z axis. So we are having the r unit vector like this. R unit vector, it is having a three-dimensional components here, like x, y, and z component. Now what about the theta unit vector? The theta unit vector, first understand that how we will write this one. The theta unit vector, it is the variation in the r vector along the theta unit vector, means the variation in r along theta unit, along theta. So it will be equal to this. It will be d, if I write r with respect to theta, how r varies with respect to theta. But as we need a unit vector here, so this is a vector r, so we will divide this by the magnitude of it, and it will be dr over d theta and the magnitude of this. So this will give us a unit vector. Now the very first thing, what about dr over d theta magnitude? So if I write this one, this is just like I vary dr unit vector with respect to d theta, because I know that if I do calculate this magnitude, means this is equivalent if I write that this is dr unit vector over d theta. The reason for writing this one is the dr vector over d theta magnitude comes out to be equal to 1, and we can calculate this one. We have already done. Let me show you here that if this r comes out to be equal to r, so we can do it. What about the magnitude of r with respect to this one d theta, and then we will take the magnitude of it. If I find the dr over d theta, then what it will be? It will become r cos theta cos phi. Then this will become r cos theta sin phi, and r minus r sine theta. So I can write this one, that dr over d theta, dr over d theta, this is our vector. So this will come out to be r cos theta, and cos phi, this one, they means the sine theta will just come out to be cos theta, and cos phi plus r cos theta again, and sine phi, and this is in y unit vector, this one is in x unit vector, and then minus r sine theta in z unit vector. Now I can square them. So in order to find the magnitude of this one, then dr over d theta will come out to be the magnitude of this one. It will come out to be r taken is common, then we will have cos theta, cos phi. So we will square them as well. So square this one. This is cos square theta, cos square phi plus cos square theta and sine square phi, and plus sine square theta, and this whole will be 1 over 2 r a square. This is the magnitude, and this is equal to r squared. Now cos square theta taken is common, so cos square plus sine square phi will come out to be 1, so it is cos square theta. Similarly, this cos square theta plus sine square theta will come out to be 1, and it is equal to 1, and this whole having power half, and this is equal to r. So we got r here. Now if I divide this whole thing by r, means the magnitude of this one, then it means that dr over d theta, this is dr over d theta. So if I write this one, the magnitude of this one comes out to be equal to r here, and in terms, if I divide this, means over r here, so if I divide this vector, if I write this one and then divide by r, then r cancellation will be done, and theta unit vector will be equal, theta unit vector will be just equal dividing the r unit vector by r. Here we divide this by r, so this comes out to be theta unit vector. So from there, just derivate this with respect to theta. So this is cos theta cos phi in x unit vector plus cos theta sin phi in y unit vector, and cos, this will come out to be minus sine of theta in z unit vector. So this is our theta unit vector, and then we can have the phi unit vector again like this, that the variation and vector are with respect to phi, and then divide this whole divide by dr over d phi, the magnitude of this one, then it will give us the phi unit vector. Now the first thing, whether if we take the r unit vector by d phi, then whether this will give us the required component, and yes, it will give, but we will have to determine this value as well. So what about dr vector divided by d phi vector and the magnitude of this one, we will have to calculate this one. So to calculate this one, let me do it directly here. Then this is our vector r. So just differentiate this one with respect to phi. So what we will have? We will have r sine theta, and then look here to this component. With respect to phi, this will go to 0 because phi is only two-dimensional, so this component is gone. Let's say I take r sine theta common from it, then it will become minus sine phi and it will become cos phi. Minus sine phi here and cos phi here means r sine theta multiplied with minus sine phi and x plus this cos phi in y. And when I will take the magnitude of this one, then it will become r square sine square theta cos square phi means sine square phi and then cos square phi, and that will be equal to 1. So we will have this thing equal to r square sine of theta, the square of this one, and here it will come out to be 1, and then we will take the square root of it. So this will come out to be equal to r sine of theta. It means when we differentiate r with respect to phi, then we will have to divide it by r sine theta as well. So divide this by r sine theta and then differentiate with respect to phi, and we will get the phi unit vector equal to, first divide by r sine theta. So this one is gone, this one is gone. Cos phi, derivate with respect to phi, and it is equal to minus sine phi and an x unit vector plus cos phi and y unit vector. So we found the phi unit vector as well, and we can see here, this thing is not that difficult even to judge from here. This is our vector projection which is in the xy plane, and phi is going this way, means phi starts from here. So along the x-axis, this phi, and then along means we will just take this one going this and then here. So this one, this component and this component, we will have like this. So we are having minus sine phi and an x and plus cos phi and y here with us is the unit vector of this one. Now I can check is like the other unit vectors. For example, we do have the x unit vector multiplied as a dot product with the x unit vector, or y unit vector with the y unit vector dot product. Similarly, z with the z unit vector, the dot product, this will always be equal to 1, and the x with y and the y with z and the z with x, they will always give us 0 as they are orthonormal. They are normalized and they are perpendicular to each other. That's why they are giving us 0 for a dot product. Similarly, if these are true, then we should have the r dot r equals theta dot theta equals phi dot phi, and they are to be equal to 1. And in the same sense, r dot theta is equal to r the theta dot phi equals phi dot r, and they should be equal to 0. And similarly, as we are having the cross product like this, that x cross y means we go x cross y, then it will be equal to minus z here. X cross y, we move, so it is plus z, it is plus z, x cross y. This is equal, if we are having this is x-axis and this is y-axis, so moving x cross y will give us the z unit vector. Similarly, y cross z will give us the x unit vector and so on. And in the same sense, here r unit vector cross phi cross theta, let's say, this should give phi unit vector, and similarly the other. So we can prove this one. I can give you this as an assignment. I can discuss them. Let's say, for example, I'm just taking r unit vector dot r unit vector. First, let me do this one, and you can do it here. This component square, because it's x unit vector with x unit vector will make 1. So this is sine square theta cos square phi, sine square theta sine square phi, cos square theta. Now here take sine square theta common, so cos square phi plus sine square phi will be 1. Then sine square theta plus cos square theta will make this thing equal to 1. So it means r dot r is equal to 1. Similarly, what about theta? I can write here. Look here, theta dot theta. So cos square theta cos square pi, cos square theta sine square pi, plus minus minus become plus, and this is sine square theta. So cos square pi cos sine square pi will give you 1. Then cos square theta plus sine square theta will give you 1 again. So we are having theta dot theta unit vector equal to 1 again here. Similarly, what about phi dot phi? So phi dot phi, square of this one plus square of this one, and it will make this thing equal to sine square pi plus cos square pi, and this is equal to 1 here. Similarly, if I want to find out the r dot theta, so r dot theta can be found, let's say, this is the r unit vector and dot theta unit vector. So I can do here, it's a bit tricky, so let me write the things here. The x component will multiply. So what it will be? It will become sine theta cos theta and cos pi. So let me write it here. What about the r dot theta? So r dot theta will become equal sine theta cos theta, sine theta cos theta, and cos pi with cos pi will be equal to cos square phi, plus the next term sine theta and cos theta, and then sine squared phi. So plus sine theta cos theta and sine square phi, plus cos theta and here sine theta, but plus and minus become minus, so we are having cos theta sine theta cos theta minus. So this term is minus here, minus sine theta cos theta. Now look here, if I take sine theta cos theta as is common, then it will become cos square phi plus sine square phi, and this will be equal to 1. So we are left only with sine theta cos theta minus sine theta cos theta, so this will come out to be 0. Rest you can prove all the relations If you are having any problem in these relations, then you can ask in the comment. I will provide you with the calculation. Now the cross product we can do as well. Let's say this the cross product will be that we are doing it for r cross phi. So this is r and this is theta. So r cross theta, it will be cross product with this one. So you will have to calculate and it will definitely come out to be equal to this. I will not do all these calculations, but I will suggest you to do these calculations. This will increase your confidence, and this will increase your intuition in the form of this coordinate system, the spherical polar coordinate system. And now we will discuss the different area and the length elements in the spherical polar coordinate system. So let's start with the area and uh, volume element here in this coordinate system. So I will retain this figure, and I will retain the x and y calculations like these two, and then we will do calculate the rest of the results. So let's start with the area and the volume calculations.